Hi, everyone. Welcome to this week's Power Corner. I'm your host, Alia Shokat, Editor-in-Chief of Power Electronics News. Today, we'll be speaking with Etienne Moulin, General Manager of Performance Power at Analog Devices. Etienne, glad to have
Yeah,
you here.
glad to be here. Thank you, Alia.
Great. So our topic today is the convergence of robotics and automotive power requirements. We hear a lot about the world of physical AI. It's almost become a catchphrase for edge computing applications. Really, with the first strong use case being autonomous vehicles. However, you don't hear as much about these systems having overlapping power requirements. I know one large trend in automotive power is the shift from 12 volts to 48 volt architectures. Are you seeing this in robotics as well? If so, why?
Yeah, I think we're seeing a great convergence between the two markets. The automotive market is relatively new to adopting 48 volt. That's something that's been around the industry for some time in wireless or in data center. And I think as robotic starts to become, as we know, more intelligent, using more of the AI processors and processing engine that are available, they really need something that's more power efficient. And to enable that technology to enter some of these new robotic systems. And so that's where we see a lot of that, I would say, ecosystem of power becoming adopted in robotic to really enable this need for higher processing power in robot. Yeah.
Okay. Um, do you see any other overlaps in power architecture between AVs and robotics?
Yeah, as we just discussed, the 48 volt rail is becoming prevalent between in robotic directly, because some of the battery would be in some of these robots would be 48 volt battery, and they need to reuse they can reuse the same architecture, and because these architecture are very power efficient, I think that's there's a great leverage of technology. Why reinvent the wheel when it's already there and moving fast, right? With automotive and also data center moving into having been pioneer in this architecture. So yeah, there's a great relevance of this architecture. I think the unique thing about robots probably would be the space constraint and the space constraint in a robot that may create a little bit more of a unique flavor of this architecture. So I think pushing the envelope a little bit further in terms of efficiency and power density in some of these robots compared to automotive, for example.
That's interesting. Maybe we could talk more about how ADI's high performance power group addresses some of these overlapping requirements with a unified approach.
Yeah, so we do have groups, especially in power, that work together. They actually under the same R&D umbrella within ADI. So we do have a great leverage across these groups. One of the leverage is around the technology, as we mentioned earlier, having technology that are very efficient, low noise, kind of low EMI, low noise, is also something that's being used in some of these segments. But also safety requirement, having a reliable power and safe power being delivered in both of these applications, because that's can create downtime in both the car or the robot that can be very impactful for the business. So I think some of this way we're thinking about power at the system level to create that high uptime and high density and efficiency are really common across this application, and we really leveraging those across this segment with our R&D.
Okay. How does the shift towards edge AI and onboard inference change the budget and thermal constraints that your customers design around?
Well, as we even though we the processing capability become higher and higher, it comes with higher power requirement, right? The processing can be packed within a smaller space, so it's we could put them in a small space, but they consume a lot of power. So what we see, the trend on this kind of trend of putting intelligence on the edge and doing some of this inference on the edge is much higher processing power. We've seen that we've seen that in the cars today. Cars from today is much more intelligent and smart than it was before. So that pushed the envelope in terms of power delivery, right? What used to be a 12-volt system to deliver power in a car now becomes 48-volt because that's much higher power content in the car. And it's the same thing with the robot. So as you put intelligence, the power delivery becomes an enabler for that technology to be at the edge, right? Because if you cannot deliver the power or you dissipate too much power, that power cannot be used for processing anymore, right? It's a communicating basis, right? If your efficiency is too low, then you cannot put as much power in it. So as you increase the efficiency, you can put more processing power in the same space. So what it means for power is compactness being the space is very critical. The efficiency is very critical. And really need to think about the power as a system of its own, right? That needs to be performing at its best and in a smaller space and the highest efficiency possible to enable that inference at the edge. So we really see power as an enabler of this new trend.
You spoke towards robotics and the efficiency requirements and how they're really constrained, potentially more than vehicles, automotive. Mobile robots such as AGVs or automated guided vehicles and autonomous mobile robots such as AMRs, they, as you were saying, they also require energy dense lithium ion batteries. Do you see any overlaps in power in terms of BMS requirements?
Yeah, absolutely. The technology and I would say the battery technology is very relevant. I think the difference you will see between some of these AMR robots and what the car would be or battery in an electric vehicle, for example, would be a difference in voltages, right? Which puts even a higher emphasis on having a very tight control of the state of the battery, the state of health, the state of charge of the battery, at a very much accuracy, much higher accuracy than even in a car, right? Because this battery, 48-volt battery, can deplete quickly, and once they deplete, they go from 90 to 10 in a very short amount of time. So having a very precise measurement of the battery monitoring of the battery and its health is very critical, even furthermore, I would say, in robot than even in cars. And because, if the robot is down, then you really is no battery, then it's down, you have to replace it or you really down a robot. So we see that as an integral part of this battery system or power system that we propose in robots is the battery monitoring system and the powertrain to get the power down to the processors, the sensors, all of that electronic that goes into it. The battery monitoring system is really critical for that for those systems.
Okay. Maybe we could talk about EMI. What are the overlaps? Are you finding robotics customers who demand power ICs and systems that meet the CISPR 25 Class 5 EMI requirements?
Yeah, absolutely. That's the environment within the car is somewhat different from what you have in industrial, but you do have a lot of electronic in the industry now, and so we do have to comply, making sure we are not susceptible or not creating too much radiation for the rest of the system. And primarily, these processors, for example, could be susceptible to some of this noise themselves, or within the system or even outside the system, are very critical. You don't want to have your Wi-Fi or your short-range radio in an industrial setting going down because of a bad EMI system, that bad design of your EMI system. So ADI has pioneered a few years ago, almost 10 years ago, the silent switcher technology that reduces the EMI and improve the efficiency with and that was primarily championed by the automotive industry, but it's still very present today. The lower your EMI you can generate, the faster you could switch. And the faster you could switch, the smaller your system could be. So all of these things are interrelated. So lower EMI is always something that's going to be winning at the end of the day because it creates less of a problem at the system level, can create even a smaller system for the end application. So all of those are really interrelated, and we really see EMI as a key differentiator for ADI.
You just spoke about the silent switcher technology,
Yeah.
and I'm sure there's many other in the ADI high performance power portfolio. Can we speak more about ADI's high performance power portfolio and how it's currently developing?
Yeah. When we mean high performance portfolio, it's really the things that are, um, you know, at the edge of the technology and whatever is, as you know, in this industry, uh, you're as good as your next innovation. So we've moved, we did the best linear regulator with the lowest 1/f noise, and then these things are great, but they're not very efficient. So we move. At the same time, we created this silent switcher technology that's low EMI. That also was a great advantage for some of these automotive applications where we move all of this technology together, where you can actually get the quality of an LDO in terms of regulation and low noise at the highest efficiency of a buck regulator. So you get the best of both worlds. So we've moved into that direction in high performance power. We also are working on these integrated µModules where we take this technology, silent switcher, and we even make it more compact and lowest EMI by integrating the inductor in a package and even shielding the package for the lowest EMI possible that we could get. So we are advancing not only I would say the IC technology, but we're also advancing on the packaging technology, and that really makes that technology unique, right? And we keep calling it high performance power because we managed to reinvent ourselves, very regularly by bringing this new technology together, either at the IC level, at the packaging level, and even going back to developing modules that integrate all of this technology and create a really differentiated solution for our customers.
Thank you. I'm curious to know a little bit more about some of those IC and packaging advancements. Like you were saying, integrating inductors in the µModules. Maybe you could
Right.
speak a little bit towards that.
Yeah, that's something we've worked. It's a technology that was initiated quite a few years ago already, where we saw this need for customers to have a very compact design. And if you're involved in power supply or in power for a long time, beside the IC, one of the second critical choice a designer makes is the inductors that will be used in that design. And we work very closely with some of these inductor manufacturers to design very compact inductors that can be integrated within the package. And so not only we work in conjunction with the inductors, but we also have our own packaging technique to embed the magnetics, the passive with the IC to create something that's not only very compact, but also very reliable and high quality for the customers. So whenever they have a very tough challenge in terms of density, in terms of efficiency, we can make this solution custom. We make this solution custom and able to integrate that at the best, or the best in the industry, right? And then again, as we say, some of this is in-house with packaging capability, and some of this we partner with passive vendors, inductor vendors, to give us the next generation of passive in terms of that can improve size and also efficiency in our design.
Thank you so much. Well, I think that's about all the time we have today. I really appreciated chatting, Etienne. It's very nice meeting you. Thanks for connecting.